Hi everyone, welcome to HPS 100, Introduction to the History and Philosophy of Science. So in this video, I'm just going to go over some of the big ideas of the course, some of the themes, and really what I'd like you to get out of the course in general. So what I'm offering you if you choose to take this course. There's another video where I'm going to go over the syllabus and the kind of course mechanics in detail. So if you'd like to know the specifics of what'll be due when and that sort of thing, please check that out. For now, let's talk a little bit about the very idea of history and philosophy of science and what I think it can do for you. So this course is put on by the Institute for the History and Philosophy of Science and Technology. All of the HPS course codes are put on by the IHPST. This is where I got my PhD. And it's usually classes are held in and around this mocha-colored pseudo-castle that you can see here. It's in the old Victoria College building, which is just north and east of Queen's Park. So this institute was founded in the 1960s, and it was founded with the idea that history and philosophy of science are actually studied better as an integrated whole. That is, you do better philosophy if you know a bunch of history, and you might do better history if you know a bunch of philosophy. That these two things sort of complement and enhance each other. And that's what we're going to try to pursue in this course. We're going to try to do some history of science informed by philosophy and some philosophy of science informed by history. To talk a little bit about each of these two disciplines, what they do separately, so we can see how they can complement each other. Talk a little bit about philosophy first. So this is sort of my home discipline. My specialization was in philosophy of science. The problem with trying to understand what philosophy is, if you're not sort of into it already, is if you ask 10 philosophers what it is, they'll probably give you 12 different answers. So there's just a constant debate about what philosophy is. But I can tell you what my favorite definition of philosophy is. It comes from this guy called Wilfrid Sellars. In one of his famous papers, he says the following. He says, quote, "The aim of philosophy, abstractly formulated, is to understand how things, in the broadest possible sense of things, hang together in the broadest possible sense of hang together." So my favorite notion of philosophy, the one that sort of inspires me and the one that I think is most helpful to people who aren't looking to study philosophy as an exclusive specialization, is just that it's the big picture. The philosopher specializes in seeing how things in general hang together. So if you think about this in terms of science, so doing the philosophy of science, you might ask yourself, which scientific discipline has as its role understanding how all of the other scientific disciplines hang together? Like, whose job is it to perform a synthesis, to see how all of the parts of science are connected? And I have a really hard time thinking of a specific scientific discipline whose job that is. So almost every scientific discipline has a focus. They have a specific thing that they're interested in. Particle physicists do particle physics, biologists do living things. It's in some sense nobody's job from within the sciences to trace out and try to integrate how all of the sciences hang together as a whole. So that's one really important job, I think, that philosophers of science can perform. If philosophers are interested primarily in the big picture, in the generalizations, in how the things are overall, historians are interested in almost the opposite. So historians are profoundly interested in the context in which things happen. So obviously they're talking about historical events, and they want to know about the context of that event. So what was happening around it? What was the sort of world like surrounding the event of interest? And one of the things that they are really good at doing is pulling out the ways in which a historical event was contingent. By contingent, what I mean is that it could have gone some other way. Right? So when you really look at the context of an event, when you know all of the subtle ways in which it's embedded in some broader context, then you can see that if it was in a different context, it might have gone differently. So this has a profoundly beneficial effect. So as I said before, I'm mostly a philosopher of science. I came to history of science in grad school. but I really learned to appreciate what they brought to the table. And what I most appreciated about the study of history, the way history is done, is their ability to show you how things that feel really obvious are actually the product of long historical sequences of events that could have gone some other way. In some sense, it's like travel. So when you travel to another country, maybe with another culture, you see all these little things that you maybe never even noticed about your own world that are different. So I grew up in Canada. When I go to another country, I often am shocked, sort of briefly shocked by the lack of things like handrails. There isn't a handrail where I expected one. And that's really nice for me because now when I come back to Canada, I can say, oh, hey, look at all these handrails everywhere. It wasn't necessary in some sense. Those handrails are a contingent fact about the time and place in which I live. So it's super duper easy, especially with something like science, to just get used to the way things are and stop noticing it. So you stop appreciating that the context that you're in is contingent. That is, the way things are around you could have been lots of other ways. Be grateful that your brain does this for you, of course, because you don't want to be shocked every day when you wake up and flip on the lights and go, oh my God, electricity. Wow, there's still electricity. Right? You don't want to be constantly astonished by the way things are. You would have a very inefficient life if you lived like that. But at the same time, you do want to have some skills, some ability to put your mind in a place where you can imagine things being otherwise. And studying history is one of the most profound and useful ways of doing that, because studying history shows us not just an imaginative way that things could have been otherwise, but real ways in which the real world was vastly different. So together, history and philosophy give us a really powerful set of tools for seeing how things are in general and seeing how they could have been different. And that really deepens our appreciation of where we are and expands our minds to the possibilities of ways that things could be. So that's the pitch, basically. What I think I can offer you is an entryway, not the full training, of course. You'd have to go through a complete degree and probably go to grad school and then spend a lifetime studying to really finish this project, but an entryway into using history and philosophy as tools to expand your perspective, get the big picture, and then get a kind of flexible openness to the different possibilities for what that big picture could have been and what it could be. So, I find this study of history to be both slightly dizzying, almost terrifying, but also in a lot of ways very comforting. So consider this graph here. So consider the moment that we're in history. As you can see, world population, this is a graph of world population over the last 10,000 years ago. The end of the last ice age, we were between 1 and 10 million humans, and we chugged along for a good long while at about that level. For 9,000 years or something, we had fairly steady population levels. And then notice that something very funny happens in the last 500 years. This curve takes a wild turn up to about 7 billion humans. And this is, if you have this sort of historical sense, the long history of our species, this is an extremely sudden and profound shift. And its causes are undoubtedly complex, but I think it would be weird to deny that science and technology have a big part of this really profound shift that we've, in a sort of biological sense, just very recently gone through. So we've gone through this incredibly profound shift as a species very, very recently compared to most of the timescales that you might think in. So this graph is one graph that has this kind of wild curve. There are some less happy graphs like CO2 or species extinction that also do this kind of really dramatic shift in the last 500 years. And I think it's worth asking, so to think back to that kind of historically minded perspective, why did it happen then? So why in this long history, why didn't in 8000 BC people invent science and have this profound shift? Why didn't it happen in 4000 BC? So what is it about the moment that we've sort of semi-recently passed through? What about that moment made it such that this is when this shift happened? And if we want to understand that shift, that seems like a good place to start. So what we'll be doing in this course, especially at the beginning of this course, is to start thinking about what we might call the building blocks of science, the parts that have to be in place for science to take off in the dramatic way that it has over the last 500 years or so. So by doing some of the history of things like mathematics, information technology, writing, printing, things like metallurgy, the manipulation of metals, medicine, and so on, what we're going to see is that it wasn't the case that, to go back to this graph, it wasn't the case that, people were just living the same way for 10,000 years and then 500 years ago something dramatic happened. Really what we can see, if we're looking at the building blocks which go into science, is a long, slow, steady development in all of those things. So mathematics has been developing for 10,000 years, medicine has been developing for that long, metallurgy, writing, so on. So from the perspective of looking at what goes into science, we can see a much less baffling shift, right? So the bits and pieces that make up the scientific process have a long, long history. And furthermore, a very global history. So these things have been developing all over the world throughout that whole time, as far as we can tell. So by tracing out the history of what goes into making science go, we can get a much clearer picture of how and why science emerges when it does and where it does. So a really nice resource for doing this, I think, is this book that's going to form most of our readings, I think, for the first month and a half or so, The Dialogue of Civilizations and the Birth of Modern Science by Arun Bala. So Arun Bala makes the case that we've been telling the history of science in some sense badly. There's a very common way of telling the history of science, which goes something like this. There was the ancient Greeks who were good at math and astronomy, and then nothing, and then the scientific revolution in the 1500s in Europe. And that goes on from there. And those are certainly very, very important moments in the history of science, and we will be talking about them. But it leaves out where some of the most fundamental building blocks for developing modern science come from. So the mathematical systems that they were using, the kind of base of observations that they were working with, the kind of the skills and tools and techniques that were required for the scientific revolution to take off the way it did in Europe in the latter half of the second millennium AD, they all came from an enormous global trade and dialogue that had been going on that whole time. So if we shift our focus a little from sort of textbook history of science to looking at where the building blocks for science come from, we get a much more comprehensive picture. We get a picture that's much more gradual. It doesn't look like a sudden, out of nowhere shift in the way people live. And we get a much more balanced picture of the development of history of science. So what we're going to start doing next week is talking about what's necessary or what's really, really helpful to have in place in order to start doing science. That includes, as I said, things like mathematics. And you probably don't need mathematics for every single scientific project, but for the ones that we'll look at the beginning, especially astronomy, it's a huge help. You need tools for observations. You need some medium in which to record those observations. And another thing that you'll need, and this is one of the most sort of philosophical elements of the course, is some kind of worldview that makes science sound like it's worth doing. So, science as a practice is pretty labor intensive. It's a lot of work. And in most of history or most of the world, people had to work pretty steadily to kind of make it through the day, to get enough food and shelter and so on. So any scientific project is taking resources away from other really practical things that you need in order to survive. So what you need in order to convince somebody to let you do science or to, find food for you while you're doing science is a worldview where it makes sense to do this. So a reason why science is a valuable activity is a necessary building block for science. And what we'll see is people in different times and places had very different stories about why the activity that they were engaged in while they were, say, learning about the lunar eclipses or learning about the properties of metals and so on was an activity worth doing. Okay, so now I'm just going to go through some of the topics. So that's next week. We'll start talking about what's sort of the building blocks for science, lay them out in general. The week after that, we'll start talking about ancient astronomy, which is one of my favorite case studies in this sort of picture because it's got an incredibly rich and incredibly old history. And pretty much as soon as you start seeing evidence of humans building cities, and probably even before that, you see evidence of humans doing astronomy, making systematic observations and recording those observations about the position and location, the movement of stars, planets, the sun, and the moon. All stuff that you can see with the naked eye, but the investment in astronomy was dramatic. And this seems to be very universal across disconnected human cultures. So we'll really only get to look briefly at this. We'll do a little taste of ancient astronomy in Mesopotamia, China, India, Greece, Egypt. Really just tiny little bits, unfortunately, because we've got pretty limited time. But I think it makes a fascinating place to start. We'll then move on to talk a little bit about, in the next week, what we may call science and empire. So a lot of ancient astronomy was driven by religion. So the idea that the heavens were somehow connected to spiritual forces. A lot of science has also been driven by political necessity. So if you're going to build a huge political empire, as many, many cultures have done throughout history, science turns out to be a very powerful tool for legitimizing your authority, bringing people together, and constructing your empire in a practical sense. So for this question, one of the key building blocks for science is undoubtedly funding, and that funding has to come from somewhere. And one of the reasons, and we'll look at various instances throughout history, of funding science largely as a political move. So we've got this picture here from the what's called the translation movement, which was early Islamic caliphates this is the sort of Islamic political organization growing very rapidly. And one of the moves that they make to integrate the societies that they've just recently sort of taken political control over is to centralize and sort of take all of the different knowledge that each of those cultures had, translate it into Arabic, and bring it together in houses of learning in places like Baghdad. So, and this seems to have been a very effective strategy for building political cohesion, building sort of the legitimacy of your authority. So we'll talk a little bit that week about that example and a few other examples of using science and funding science for the purpose of strengthening your political organization. We'll move on to the Copernican revolution. That is, sometime around the 1500s in Europe, there was the kickoff of what we might call the scientific revolution. There's a lot of different sort of points at which you might say that that started, but a crucial one was this astonished looking fellow here, Nicholas Copernicus, who was one of the first people to present a serious model of the solar system where the sun is in the center and the earth goes around the sun. So this is part of the sort of traditional story of the history of science, but I'd like to tell it from the perspective of, so Arun Bala, in his book that we'll be reading, talks a lot about how Copernicus's achievement is made possible by an influx of ideas and techniques and technologies coming into Europe at this time. So, for example, Copernicus is working with Arabic numerals, that is, the numbers that Westerners use to write 0 to 9. And I don't know if you've ever tried to do math in ancient Roman numerals, but it is very challenging. It's a lot of work. So he's got this really efficient technology recently imported from, or recently, the last few hundred years, imported from the Islamic world, who before that got it from India. So there's this sort of global trade of mathematical, numerical technologies. And Copernicus's sort of achievement of correctly modeling roughly the shape of the solar system depends on these technologies coming together in Europe for various reasons. So we'll look at how this came to be, how Copernicus got to build his model, and also how it affected the ways people thought about the world. So we'll trace out the worldview that's both the one that's sort of pushed out and the one that gets introduced. So we're only going to be able to do this briefly. If you want to know more about this, there's lots of good sort of resources at the IHPSD. So HPS 200 Scientific Revolutions goes into much more depth than we'll be able to go into in this class. So if you find this one interesting, please go see HPS 210. We'll also talk, so the week after, we'll talk a little bit about the relationship between science and religion. So I think it's the sort of received wisdom that science and religion are, in some sense, in permanent conflict. Like if you ask the average person, they might tell you that these things are in a sort of fight. And the poster boy for this fight is probably Galileo. So Galileo was a defender of the Copernican system. He said that the earth goes around the sun, and the accepted wisdom is that Galileo was terribly mistreated by the Catholic Church for having said this. So I'll look at this as a case study. And I think if we look at the details of this story, what we find is that the truth is a lot more complicated than that. In Galileo's time, and far beyond Galileo's time actually, the church was one of the biggest funders of science. They fronted the money. They were the ones pushing the scientific project in a lot of ways. Now, they had specific reasons for doing so, and they weren't exactly the same as the reasons as, say, a contemporary body that funds science. So we'll have to look at the kind of motivations of religious funding for science, but I'm going to make the case in that week that the relationship is much more complex and subtle than just religion and science have a fight throughout history. Okay. We'll spend a week talking about what we might call the mechanical worldview as well. So this is the idea made popular during the scientific revolution, but present throughout history in a bunch of locations, that the world is basically just explainable in terms of things pushing and pulling against each other. So the mechanisms are how you really explain the world. And I'm going to contrast that with what you might call the Aristotelian worldview. So Aristotle's thinking was popular throughout the West, throughout the Islamic world for a couple of millennia. And Aristotle saw the world as full of meaning and purposes and significance. And the scientific revolution sort of tries to erase that stuff from our way of thinking, and in some sense was profoundly successful in doing so. So we'll talk about how the mechanical worldview was a shift in philosophy that seemed to really invigorate the scientific process. The week after that, we'll talk about alchemy and chemistry. So alchemy was this sort of very rich, very complex, and very global again. So lots and lots of people around the world doing this practice of manipulating physical substances. Now they had, this is interesting, I think, from the perspective of what makes science possible. So alchemy was a pretty strange process by modern standards. So many alchemists, so this is a similarity between European alchemy and Chinese alchemy, for example, saw alchemy as both manipulating something external, but with the goal of perfecting and refining the inner world of the person doing the practice. So that's probably not the case in modern chemistry. I take it that when you're in a chem lab, they don't think that you're also elevating or refining your soul much at all. So alchemy has this quite, to the modern scientific ear, quite strange worldview. But nonetheless, without the long practice of alchemy, exploring the material properties of things, of metals, of salts, of various sort of physical substances, we wouldn't have the tools, the techniques, the practical skills that were necessary for chemistry as a kind of modern scientific thing to take off. So this is again about the question of what makes science possible. We'll do a little bit on early modern medicine, another fascinating area, particularly for the global circulation of knowledge. So when we look at the early modern period, what we find is huge amounts of global travel, trade, and sometimes exploitation of various bodies of knowledge, bodies of medical knowledge. And what we'll look at, the reading that we'll look at is about Tamil medical knowledge being exported to Europe in the early modern period. History of medicine is a very strong point for the IHPSD. So here are some more advanced history of medicine classes. We've got some really excellent historians of medicine. So if this tickles your fancy, please check out these courses as well. We'll do a little bit about Darwin and Darwinism. We're getting quite modern now. So Darwin's theory of evolution is an example of a few things. First, again, the global circulation of knowledge, because Darwin's theory was built on a huge number of data points, and those data points were collected essentially as part of the colonialist project. So, of course, he had information about what was going on in Britain and the kind of Western Europe more generally, but that wouldn't be good enough for a theory about all of life. For a theory about all of life, you want examples from all over the world, and he got those examples because people were sailing around the world, Europeans were sailing around the world at this point, collecting biological samples, bringing them back, classifying them, and so on. This is also a super interesting case study for the interaction between science, society, and religion. So Darwin's theory comes to take on a variety of kind of political and social significances, and of course kicks off a kind of very contentious dialogue between the religious and scientific worldviews. So we'll talk about that as well. We'll talk a little bit about placebos in modern medicine. A kind of interesting perspective on medical authority and its relationship with science. And it's also tied to the kind of, I think it's one of these points where history is very revealing. It's very nice to sort of get a fresh perspective from before our own time, because things like the double-blind placebo-controlled experiment are totally standard, and it's easy to imagine that that's just always been the way people did things. But that's actually a fairly recent innovation in scientific methodology. So we'll look at that. And we'll finish off with a little bit of history of artificial intelligence. Relatively modern history, 21st century, but with some interesting philosophical roots that go back to things like the mechanical worldview. And I'll talk a little bit about those relationships when we get there. We've got some brand new courses at the IHPSTA about the history and philosophy of artificial intelligence. I think these are really exciting. It's hard to think, from my money, of a more relevant thing to think about in the development and the history of science right now. So check these out if you're interested. Okay, so that's roughly the course. I hope you're interested. I hope that this course has something to offer you. And I hope that this is interesting to both science and humanities students. So for wherever you're from the university, I think we've got something that will be worth your time. Thanks.